Good day, everyone! I'm Brian Franciscine.
And I'm Narisa D. Utara.
I'm going to prove the Euclidean geometry.
And I'm going to prove the non-Euclidean geometry. Alright class, before we will differentiate the difference between the Euclidean geometry and non-Euclidean geometry, we must first understand its concept. First, in Euclidean geometry.
So these 5 postulates are the foundation of Euclidean geometry. Postulates known as axiom. This statement is accepted as true without proof. So lines, points, and planes.
Alright, I see. So now you are ready to know the 5 postulates.
So the first postulate is through any points there is exactly one line. So I have here white marker. So I put here 1, 2, or just move this 1. So I prove that there is exactly one line. So can you prove to be in the spherical in any 2 points there is a line?
Alright, let's see, partner. So using again a marker, I'm going to put 2 points on it, okay? Any 2 points. Here we go. And that it creates a line. Okay, using a rubber band. Alright. Okay, if you notice, we form a line using a rubber band with the 2 points. In other words, in a non-Euclidean geometry, it is true for the first postulate. For postulate number 2, through any 3 points not on the same line, there is exactly one plane.
So in Euclidean geometry, so according to the second postulate, there is in 3 points not in the same line, so this is the plane. So this is true. How about you?
Alright, for the non-Euclidean geometry, as stated, it has 3 points. So using a marker, if you notice, I have a lot of lines here. So in this first line, I will create 1 point. So I can have it here. And for the other line, another point. And for this line also, another point. So I created 3 points. So if you notice here, so in other words, in the line postulate 2, we created a plane. So it is true for postulate 2.
So in the third postulate in Euclidean geometry, a line contains at least 2 points. So here, 1, 2. At least 2 points consist of one line. How about you?
Alright, for the non-Euclidean geometry, I have here 2 lines. As stated, we have to make 2 points to form at least a line. So here in this line, 2 points here and here. See? In other words, it is true for non-Euclidean geometry. Postulate number 4. All right angles are congruent.
In Euclidean geometry, this plane here, and using a protector to visualize, we put a marker so that we can see the 90 degree. So here, measure this first square, the big one, and the small one. So here and here, there are congruent.
Alright, how about for the spherical geometry or for the non-Euclidean geometry? Let's see if all right angles are measuring 90 degrees. So using again with the protractor, let's see. So here, okay, that is 90 degrees. For the next, 90 degrees, 90 degrees, and the last one, 90 degrees. In other words, for non-Euclidean geometry, postulate 4 is true.
So the fifth or the last postulate for the 5 foundational of Euclidean geometry states that given a line and a point not on that line, there is exactly one line. Through that point is parallel to that line. So here, use this square, this line, one line, then a point here, point. So can create one line or here a line. So we have two lines here and here. So there are parallel.
Alright, how about for the spherical geometry? Let's see if this postulate number 5 is true. So I have already here a line. And according to the definition, there is one point which is parallel to this line. Let's see. So using a rubber band. Alright, if you notice, it intersects to the other line. In other words, the postulate 5 is not true for spherical geometry.
What? That's crazy!